Hello, everyone. My name is Ido Benartzi, and I'm a graduate student from Tel Aviv University, where I study reinforcement learning and psychopathology in Dr. Nitan Shachar's lab. I also was a student in Neuromatch Academy, Computational Neuroscience course 2 years ago, and I'm glad to be able to help you to learn more about polynomial regression today. So polynomial regression is just another kind of linear regression, as you learned before. And the only difference is that we are describing a relationship between x and y that can't be well described by a line. So we're using features from a higher degree, higher power. For example, we can think about the relationship between stress and performance. And As we all know, it seems a little bit like an inverted U shape, right? So if we're too stressed, it's bad. If we don't care at all, it's also not so good. So the best values are here. So that's only one example, but we have many examples in neuroscience and behavior that are best represented by those kinds of relationships, either parabolic or hyperbolic, and so on. So for example, we can have this data here to simulate this kind of a relationship. Here it's not an inverted U, but just a U shape between X and Y. And we want to find the weights of X to the power of 1, X to the power of 2, to the order that we want, that best describe this relationship, okay, between the X and the Y here. Cool. So for this, we need our design metrics. What we will have in our design metrics is in the rows, we will have our data points. So each row will be a data point or a sample. And every column will be a different feature. In this case, it won't be really a different feature like we had before, for example, like height and weight, so x1 and x2, but it will be like x to the power of 1, x to the power of 2, just different orders of the same feature. Another thing that we should notice is this one here, which represents the zeroth order or the intercept, the bias. Yeah. Okay, so let's move to creating this design matrix. So the first thing we do when we get to a function is we see what are the parameters that it's getting. So we see it's getting the x and the order, and this is what it does. We see x is a vector that has the shape of the number of samples. Here it's 30. And the order, okay, so to what order do we want our features to get? And the output is the matrix, the design matrix, which will have the samples on the rows and the order +1 because of the intercept on the columns. So we need to first comment out this line. And then the first thing we do is we change our vector x to a matrix by adding a non-dimension. Then we first create the intercept column by just creating ones column. And then what we do is just we add columns of the degree of x that we want. So we do it by using the NP NumPy 8 stack. And the input it's getting is what we want to add to. So it's the design matrix here. And the for loop is giving each time x to the power of the degree. Okay. So each time it will add the column. That's it. Here we can run it, and we see the first two columns, the intercept and x to the power of 1. That's it. Thank you, and good luck.